Hi everyone. So I'm gonna do an exit ticket run through really quick. So today our first problem is to find two positive numbers whose product, I'm gonna switch this out from 750 to 250, and for which the sum of 1 and 5 times the other is a minimum. So our constraint equation is gonna be this first part, right? Find two positive numbers whose product is 250. It tells us straight up, this is a rule that we have to follow. So two positive numbers, let's name them x and y. So x times y is equal to 250. That's our constraint equation. Now our optimization equation, again, is the equation that we want to like maximize or minimize. And that's gonna be the second part of this problem, which says, so find two positive numbers and then for which the sum of 1 and 5 times the other is a minimum. Right? So that means the sum of one of the numbers. So let's say the sum of x and 5 times the other. So let's say x plus 5 times y. So that's what it's really saying. X plus 5 times the other. So the sum of one, in which case is x, plus 5 times the other, is a minimum. So we're going to want to minimize this. So let's just call this f is equal to x plus 5y. And we're going to want to minimize this. Now we're going to solve for the answer, right? So our answer is going to be, well, first we're going to want to substitute in one of the variables for the other, right? So we're going to want to minimize f is equal to x plus 5y, but that's not very easy to do because we have two variables. So let us substitute in let's say, substitute in y for x. So we're going to say from the first equation, from the constraint equation, we're going to get y is equal to 250, or sorry, x is equal to 250 over y, right? From here, we just divide both sides by y and we get x is equal to 250 over y, right? Then we're going to get f is equal to 250 over y plus 5y, right? So we're substituting in x for here. So now we have this new equation that we can focus on, right? And we want to minimize this still. And remember, it's always important to substitute in whatever we want into the optimization equation because that's what we want to minimize or maximize. So then once we hit this, let us now find the critical points. And we do that by finding f prime. So f prime, or the derivative, right? So the derivative in this case, actually, before I do that, I'm going to rewrite this so we can use power rule more easily. So 250 times y to the negative first power plus 5y, right? So f prime is going to be equal to negative 250 plus 5. Sorry, negative 250, right? So negative 1 is multiplied by 250 times y to the negative second power plus 5. Right, so now we are going to set this equal to 0. Right, so then we're going to get negative 250 y to the negative 2 is equal to negative 5. Now let's cancel out the negatives. So we're going to get 250 y to the negative 2 is equal to 5, right? So then we're going to multiply. We're going to, here, I'm just doing some algebraic manipulation on each of these steps. Right, we're going to bring the y squared down. Then I'm going to bring this up here. Let's multiply both sides by y squared, right? So it's going to be 250 equals 5y squared, right? We multiply both sides by y squared. Then we divide both sides by 5. So divide by 5, right? So then we're going to get 50 is equal to y squared. So y is equal to square root of 50, which is equal to square root of 4 times 20. Oh, sorry, 2 times 25, which is equal to 5 root 2. So y is equal to 5 root 2. Now we just have to figure out, actually before I circle this, we have to figure out that it's actually a minimum and not a maximum. So let us make a number line to see if when y is 5 root 2, it's a minimum rather than a maximum. So we're going to plug in a number to the left of 5 root 2. So let's plug in, let's say 1, and then we're going to plug this into f prime, right? Because we're plugging it into f prime to find what the slopes are, to see if it goes from positive to negative. If it goes from positive to negative, then it's going to be a maximum, right? If it goes from negative to positive, it's going to be a minimum. So when we plug in 1 here, right, I'm going to get f prime, right? F prime's over here. So I'm going to get f prime is equal to negative 250 times 1 plus 5, right? So that is equal to negative 250 plus 5, which is equal to negative 245. So it's clearly very negative, right? So basically, if you're doing this for your problem, you're just are gonna plug in a value to the left of 5 root 2 into that equation, into your derivative equation. Then on the right here, let's plug in 10, let's say, because that's larger than 5 root 2. So f prime is equal to negative 250 times 10 to the negative 2 plus 5. So it's equal to negative 250 over 10 plus 5. I'm sorry, 10 squared plus 5, right? So then that's going to be equal to negative 250 over 100 plus 5, which is equal to negative 2.5 plus 5, which is equal to 2.5. So it's positive. So we have negative going to positive. That means it is indeed a minimum. So we know that 5 root 2 is equal to y. That is indeed a minimum. Now to find x, simply plug 5 root 2 back into this equation. So x times 5 root 2 is equal to 250. And I'm not going to do the exact calculations, but it's going to come out to be x is equal to 250 over 5 root 2. Sorry, that is a terrible 5. Cool. So yeah, y is equal to 5 root 2, x is equal to that. I did not calculate that out, but that is our answer. Now for the second problem, we want to create a box with an open top and square base with a surface area of 300 square inches. What height will produce a box with maximum possible volume? So I'm just going to do this problem for everyone, just because I think this is going to be pretty difficult. So first we want to create a box with an open top and a square base. So let's just draw a box. And then we know it has a square base, so I'll draw the square base first. So I was practicing drawing boxes earlier, but okay, so let's just say that's a square base, right? And then it's a box. So okay, that's probably not the best box, but hopefully you can kind of see that. It's got an open top though, so the top is open, there's nothing there. And as a square base with a surface area of, so we want to create a box with an open top and a square base, right? With a surface area of 300 square inches. So the whole thing, the whole box has a surface area of 300 square inches. So that means, I don't have anything box shaped next to me, but that means the bottom of the box, and then you add the 4 sides of the box, right? So it'd be the bottom of the box here, and then you add each of these 4 sides, right? So I think this, okay, that made it worse, but each of these 4 sides, and that is equal to 300 square inches. Note that we are not adding the top of the box, right? This top here in our surface area calculations because it's open. So how do we come up with an equation for this? Well, let's think about this. It has a square base. So that means that each side of the bottom of the box is the same length. So that means if it's x here, then this is also x because it's a square base, right? Now the height, we don't know. We don't know what this is, h. It's not necessarily a square box, right? Only the base is square. So, but what we do know now is if we have these dimensions, we know that the surface area, which is equal to, surface area is equal to, it's 300 is equal to, we're going to add the base of the box, so it's going to be x squared, right? Then we're going to add h times x, right? That's one side of the box, plus h times x. Then we have the other side of the box. So like this side, this side, this side, and this side. And if you think about it, it's a box. There's 4 sides. So actually, it's going to be 4hx. So this is our constraint equation. 300 is equal to x squared plus 4hx, or if it makes you more comfortable, x squared is equal plus 4hx is equal to 300. And we don't know x or h. But next, let's find the optimization equation. What height will produce a box with the maximum possible volume? Well, we want to maximize the volume, right? Well, that's pretty easy. Volume is equal to length times width times height. So in this case, it's x times h. So x times h is equal to x squared h, right? So really, we want to maximize x squared h. Okay, well, let us substitute in a value, right? Because we have, again, 2 variables here, 2 variables. That's not very good. It's hard to optimize that. We want just 1 variable so our equation is easier. So I'm going to substitute in, I'm going to solve for h in this top constraint equation. So x squared plus 4hx equals 300, right? I'm going to subtract x squared from both sides. So 4hx equals 300 minus x squared. So h is equal to 300 minus x squared over 4x, right? So I divided by 4x on both sides in that step. So just to make this easier for power rule, h is equal to 300 over 4x minus x squared over 4x. H is equal to 300 over 4. I'm going to bring the exponent to the top, so x to the negative first power, right? So we bring x from the numerator to the denominator, now it's a negative exponent, minus, I'm going to divide by x on both sides, so x over 4, right? We just cancel out an x. So now we have, sorry, wait 1 second, let me just check that I did this right. Cool, so we have h, right? Now we're going to multiply, we're going to put in h into the volume equation. So volume is now going to be equal to x squared times h, which is now 300 times x minus 1 over 4 minus x over 4, which looks really complicated, but actually simplifies quite nicely. So v is equal to x squared times 300 x to the negative first over 4. That's just going to simplify to 300x, right? Because x squared times x to the negative 1 is just going to be x to the 1. And then when we multiply these 2 terms, so x squared times negative x over 4 is going to be negative x cubed over 4. Now we're going to want to find the derivative, right? Because we want to maximize, maximize this. And we finally have it so that we have it just only 1 variable. We have just x. So v prime is equal to 300 over 4, right? Because it's just 300 over 4x, so it's like 2x. The derivative of 2x is just 2. Minus, we're going to do power rule here, so 3x squared over 4, right? We're going to set this equal to 0. Now to find what x is equal to, we're going to multiply both sides by 4, right? So we're going to get 300 minus 3x squared is equal to 0, right? We multiply both sides by 4. The 4's basically just cancel out because we can multiply both sides by 4, and then 0 times 4 is still 0. Right. Now we're going to move 3x squared to the other side, so 300 is equal to 3x squared. So then I'm going to divide by 3, so x squared is equal to 100. So then we have x is equal to 10, right? So x is equal to 10. Now the question is this a maximum or a minimum? Right, so let's see, we put x equal to 10. Let's plug in something over here. Let's plug in 0, right? So we got to plug this into v prime. We got to plug into the derivative equation, right? So 0 is actually going to go into this equation right here. So 300 over 4, it's going to be, sorry, I'll write it out. So it's going to be 300 over 4 minus 3 times 0 squared over 4, right? That is going to be equal to 300 over 4, because this just cancels out to 0. So it's just going to be 300 over 4. So it's going to be positive. Right, now let's plug in a number to the right of 10. Let's plug in 20, right? Let's plug in 20. So now we get 300 over 4 minus 300 times 20 squared over 4. And that's equal to 300 over 4 minus 3 times 20 squared. That's going to be 3 times 400. So that's going to be 1,200 over 4. So that's clearly negative, right? Like 300 over 4 minus 1,200 over 4 is going to be equal to negative 900 over 4. So that's clearly negative. So what this tells us is that 10 is indeed a maximum. It goes from positive to negative, so at the top of the hill. So it's indeed a maximum, so x equals 10 is a maximum. But the question is, what height will produce a box with the maximum possible volume? So to get the maximum height, we just simply plug in x is equal to 10 into the constraint equation. Plug it in for x over there. So we're going to get 10 squared plus 4 times h times 10 is equal to 300. So that's 100 plus 40 h is equal to 300, right? We just multiplied this 4 and the 10 to get 40. Then we're going to subtract 100 for both sides. So 40h is equal to 200. We're going to divide both sides by 40. So h is equal to 200 over 40, which is equal to 5. So h is equal to 5 when the maximum height. Yeah, when to get a maximum possible volume. That's now particle motion. So this should be really quick. If a car is moving according to a position, so this is a position equation. Remember our thing is a position equation. F position is f of x is position. That's position, but anyway. Then f prime of x is velocity, which is just like how fast you're moving, like 10 miles per hour. And velocity can also be thought as like change in position, but f double prime of x, so the second derivative is acceleration. So if a car is moving according to the position of this equation, so we know we're over here, right? Provide the equation that will give us the velocity of the car. Okay, so velocity is going to be the first derivative. So let's just use power rule, right? 4x cubed, that's going to turn into 12x squared for power rule, right? 3 times 4 is 12, and then subtract 1, so it's going to be 12x squared minus 2, right? So that's our velocity equation. We already finished the first part. And provide the equation that will give us the acceleration, okay? Acceleration is just doing the power rule again, right? It's the second derivative, so it's going to be 24x, so acceleration equation. Additionally, is the car speeding up or slowing down at x equals 2? Well, think about it. Is speeding up or slowing down, what is that testing? So remember, velocity is change in position, right? So that's a good way to think about it. Each derivative, like the derivative of position is velocity, which is change in position. Now the derivative of velocity is acceleration, which is change in velocity. So it's like change in speed, change in how fast you're going. Well, that's exactly what this is asking. Is the car's speed, is the speed going up or is it going down, right? At x equals 2. So it's asking about acceleration. So let's just plug in 2 for x here. So it's going to be 24 times 2, and that's equal to 48. So it's positive. So it's speeding up. So it is accelerating. the car is speeding up there. Hopefully that makes sense. If you have any questions, please message me. I did go through this really quickly, so hopefully this makes sense.